Okay, so right now we are going to work on problem number 3, which is bisection method. So first thing it is asking us, set up the following table. Calculate the number of steps to find a root accurate up to 4 decimal places, and then calculate the steps to find the root using bisection method. Okay, so first I'm going to find the number of steps we need for a root which is accurate up to 4 decimal places. Okay, that means absolute error will be 10 to the power negative 4. That means your absolute error will be 10 to the power negative 4. Very small. Number of steps n should be less than or equal to b minus a. We said there is a root in 4 to 5, so that's my interval a to b. Right, my interval is a to b, so my b is 5, a is 4, b minus a is 5 minus 4, which is 5 minus 4, which is 1, divided by your absolute error is 10 to the power negative 4. That means you want a root which is correct up to 4 decimal places, right? Okay, so maybe if I say this, that means 10 to the power negative 4. Okay, so 5 minus 4 is 1. 1 divided by 10 to the power negative 4. 1 divided by 10 to the power negative 4 is 10 to the power positive 4. Okay, less than or equal to log 2 base 10 to the power positive 4. If I just put this one in my calculator, how can you put it in calculator? Either you need to go to math, and then go all the way down to log base, and then you can complete log 2 base 10 to the power 4. Or in my Desmos calculator, I am showing you guys how to find that log 2 base, right? Okay, so log 2 base 10 to the power 4, so 10 to the power 4, and then I'm completing. So this is giving us 13.28 something, and should be less than 13.28. 13.28 is a decimal number, n is the number of step, so it cannot be a decimal number. Number of step need to be a whole number. So let's put n 14. That means you need 14 steps to calculate with bisection method to get your root correct up to 4 decimal places. But I'm not asking you guys calculate 14 step. I'm just asking you calculate up to the 3rd step. Okay, so this is my number of step. A is the smaller value of the interval, starting value of the interval. B is the ending value of the interval. That means if you are working in the 4 5, then your starting point is 4, interval is ending at 5. C is equal to A plus B divided by 2, and then you need to calculate f of C to find out which one you want to replace in the next part. Okay, now we found that our f of 4 is positive, right, and f of 5 is negative. Okay, n is equal to 1. This is my first step. I started with 4, and at 4 function is positive, so I'm just putting a plus sign here to show that at A function was positive, and at B, which is 5, at 5 function was negative. Let's go to the graphing calculator again. So what was the function? X minus ln x to the power x. At 4 function was positive, at 5 function was negative, and we are saying there is a root between 4 and 5, right? And there is a root between 4 and 5. Here is 5. Let me make this one bigger. 4 and 5. So right now what we are saying, at 4 function is positive, at x equal to 4 function is positive, at x equal to 5 function is negative, and right now we are saying there is a root between them. We are bisecting the interval at 4.5 and checking what is the function value at 4.5. This graph is showing at 4.5 function is negative. Okay, so 4 plus 5 divided by 2 is 4.5. At 4.5 function is positive. So which one I want to replace on next step? In next step, this one was saying there is a root between 4 and 5 because at 4 function is positive, at 5 function is negative. Now I found that at 4.5 function is positive. Is it? At 4.5 function positive? Let me check again. Sorry, at 4.5 function is negative. At 4 function is positive. At 5 function is negative. What is happening at 4.5? 4.5 function is negative, right? So here is the negative value. Now I am going back. At 4.5 function is negative, less than 0, not greater than 0, less than 0. So what is happening? At 4 function is positive, at 4.5 function is negative, so there must be a root between 4 and 4.5. Okay, so go back again to the graph. At 4 function is positive, at 4.5 function is negative, so right now we are saying there is a root from between 4 to 4.5, and we can see there is a root between 4 and 4.5. Okay, so right now we are dividing this interval 4 to 4.5, bisecting it, that will give us 4.25. 4 plus 4.5 divided by 2, 4.25. I need to check what is the function value at 4.25. So I'm going to the calculator. I want to see what is the function value at 4.25. 4.25 function is negative. So at 4 function is positive. At 4.25 function is negative. So there is a root from between 4 to 4.25. This one is negative. Okay, so in third step, 4 is still staying same. 4.25 is giving us a negative value, so there is a root between 4 and 4.25. Now what is the middle point? 4.25 plus 4, and then we are dividing by 2, which is 4.125. 4.125. Okay, and then we are saying this is the root after third step. You can calculate up to 14th step to get better answer, but right now we are saying at the end of third step 4.125 is the root. Okay, at the end of third step. So let me go to the graphing calculator and see what is happening at this point. 4.125. So you can see we are very close. This is 4 and here is 4.125. 4.125 is here. 4.125. And then let's make this one more bigger. So at 4 we have function is positive. At 4.125 we have function is negative. At 4 function is positive, at 4.125 function is negative, and we are very close to the actual root, which is 4.099. But if you calculate more steps, you will have more better answer. Right now we just want to make sure that we understand the steps, what we need to do. So after third step we have our root is 4.125. Okay, and then I am stopping here. This video is stopping here.